Hello everyone and welcome to my presentation on hypothesis testing. My name is Baran and in this video I will be walking you through the fundamental concepts of hypothesis testing, the definition behind hypothesis testing, why it's essential for data analytics, the key steps involved, and I will be using Excel to apply hypothesis testing to one sample t-test and two sample t-tests. So by the end of this presentation, you'll have a clear understanding of the key steps involved, along with the practical examples on Excel to illustrate each stage. Before we dive into the steps of hypothesis testing, let's start by looking at some key definitions. Hypothesis testing is a method used in statistics to draw conclusions about a population based on a sample. Essentially, it helps us make decisions or inferences using data rather than relying on assumptions or guesswork. Next, we have the null hypothesis, often represented as H0 here. This assumes that there is no effect or no difference between the groups or variables. For example, it might state that two population means are equal. In contrast, the alternative hypothesis, abbreviated as H1 here, assumes that there is an effect or difference between groups. This is what we usually want to test for, to see if the data provides enough evidence to reject the null hypothesis. So let's go through the steps involved in hypothesis testing. So in this there are 6 main steps in the process. Step 1 is we state the hypothesis, which is here where we clearly define both the null and the alternative hypothesis. This sets up exactly what we are testing for. Step 2, we set the significance level, which is usually denoted by alpha. This is the threshold we use to decide whether to reject the null hypothesis. Usually it's set around 5%. Step 3, we calculate the test statistics. We use the sample data to compute a test statistics, which in our case, we use the t-value, depending on the type of test being used. We're only using t-value here, we're not using z-value because we do not know the standard deviation, right? Step 4, we find the p-value. The p-value tells us the probability of observing our results or something more extreme, assuming the null hypothesis is true. Step 5, we make a decision. We compare the p-value to the significance level. If the p-value is less than alpha, we reject the null hypothesis. If not, we fail to reject it. Step 6, we interpret and conclude. This is where we interpret the result in context. We explain what the decision means for the original research question or business problem. Next, let's look over at the one sample t-test. A one sample t-test is used to check whether the mean of a single sample is significantly different from a known or a hypothesis population mean. In other words, we are testing whether our sample provides enough evidence to say that the population mean has changed or differs from what we expect. For example, here we are asking, is Melbourne's January average maximum temperature in 2024 is significantly different from the historical January average of 25.9 degrees Celsius? Our null hypothesis H0 states that the mean temperature is equal to 25.9 degrees Celsius. Our alternative hypothesis H1 states that the mean temperature is not equal to 25.9 degrees. If the t-test results in a p-value less than our significance level, we would reject the null hypothesis and conclude that 2024's January average temperatures are statistically different from the historical average. I'll be applying these examples on Excel. So this here is my data set for the one sample t-test. All data is sourced from the Bureau of Meteorology. Column A shows the days, how many days there are in January, so it's 31 days, that is the sample size. And column B shows the temperature in Melbourne on each of the 31 days, right? So the population mean is set at 25.9, that is the historical average. And now we have to, first we need to calculate the sample mean. So the sample mean is the average of the sample. To calculate the sample mean, we have to use the average function and then use data from B2 down to B32. Yep, so sample mean is 25.32 rounded to 2 decimal places. Now we need to calculate the standard deviation. So the standard deviation measures dispersion and the spread of the data. In order to use standard deviation function, we have to use stdev dot s and drag the data from B2 to B32. So our standard deviation is 4.02 rounded to 2 decimal places. Now we have to calculate the sample size, right? It's fairly easy. Use the count function and drag the data from 1 to 31, so from cells A2 to A2. So now we have to calculate the test statistic. So the test statistic tells us how far the sample result is from our null hypothesis. So to calculate the test statistic, we have to equal brackets sample mean minus the population mean, close brackets, over the standard deviation square root. We square root the sample size. Okay. So our test statistic is minus 0.80, rounded to minus 0.801. Now we have to calculate the p-value. So the p-value refers to the probability of observing a test statistic that is as extreme than the one calculated. Okay. So to be able to calculate the test statistic, we have to use the t.dist 2t function. So 2t stands for two tails. We take the absolute value of the test statistic, and then we have to calculate our degrees of freedom, which is the sample size minus 1. So that is 30. And our p-value is 0.43. So to wrap up the one sample t-test, the results show that there is no significant difference between the sample mean of 25.3 degrees Celsius and the population mean of 25.9 degrees Celsius. The calculated test statistic was minus 0.80 and the p-value was 0.43, which is greater than our significance level of 0.03, much greater than 0.05 in fact. So because the p-value is not small enough to reject the null hypothesis, we fail to reject HO, which means that there isn't sufficient statistical evidence to conclude that Melbourne's January 2024 average maximum temperature is different from the historical average. I'll now be moving over to the two sample t-tests. The two sample t-tests test whether the mean of two independent groups are significantly different from each other. So in this example, we are testing whether Melbourne's January average maximum temperature in 2024 is significantly different from Sydney's January average. So we are using two data sets for this on Excel. The null hypothesis states that Melbourne and Sydney have equal means. The alternative hypothesis, H1, states that the means are not equal, meaning there's a significant difference. I will be applying this on Excel next. So here's my data set for the two sample t-tests that I'll be conducting. This time I'm comparing Melbourne's January average to Sydney's January average maximum temperature. All data is sourced from the Bureau of Meteorology website. So in order to conduct my two sample t-tests, I could enter the data manually, but this will take a lot of time. So the easiest, much simpler way to conduct the two sample tests is through the data analysis. I'm using data analysis toolpack. So I select the t-test two sample assuming unequal variances, press OK. So I first need to input the variable 1 range, which will be the Melbourne variables. So from B1 to cells B32. Variable 2 will be Sydney data. So I'll be using cell C1 to cell 32. Our hypothesis main difference is 0. I will be including labels. Labels includes Melbourne and Sydney. And for my output range, I'll be using cell F6 because I want it on the same page. Otherwise, it will be on different pages. I press OK. So here the t statistic is minus 3.34, which is well beyond the critical value, and the two-tailed p-value is 0.015. Since this is below 0.05, the difference between the two means is statistically significant. So in conclusion, as the two sample t-tests show the significance difference between the mean temperature of Melbourne and Sydney, we reject the null hypothesis, and we conclude that Sydney is significantly warmer on average in January compared to Melbourne.